groups have commented on our one page saying that to one hobby, because if you want to just make a groups out of all hobbies, it will look like one meetup.
It will look like what?
A meetup, there's an app called Meetup that's kind of like, used to create these kind of social groups.
Okay, so he's saying
He's saying
don't do it because there's already
he's saying like stick to one particular hobby and stick to a particular.
Why? Because there's already an app that.
I mean, we can discuss it.
Okay.
Try to explain like if there's something different from Meetup and app.
Alright, let's go. Everyone, so we will explain how you can make a responsive UI in Flutter. Guys, let's start our presentation. This team has worked so hard to give us a good overview. These are the things that we will cover in our presentation. So first is, why do we need responsive UI? And there are three ways to approach it. The first is media query, second is layout builder, and the third is responsive framework library. And lastly, we'll do the comparison between all the three ways. And we will show you how we will implement this in the code as well. So firstly, why do we need responsive UI? So it is for the better user experience. So whether you are using that website on your app, your desktop or your tablet, it should be user friendly. So we use this responsive UI for that. And so there are three ways we can implement the responsive UI in Flutter. The first is your media query. So it is just a class that allows for access to device information like screen size and orientation. So media query is just like a CSS in a web application. Like, have you ever implemented a CSS in your web application? Like, you can just get the screen size of particular pixel and then change the UI according to that. And the second is your layout builder, widget that adapts to constraint of its parents, giving precise control over layout adjustment based on available space. So we will explain you in the code. You will get it better when we'll explain the code. And the third is the library. So it is a powerful Flutter package used for building adaptive UI with as provide custom breakpoints, automatic scaling, and responsive wrapper.
So briefly going over media query, like Future said, it pretty much is a class that allows you to access the device information on like screen size and stuff. So simply using it in terms of, hey, if my screen size is a certain, like the width is a certain amount of pixels, then I want to use this layout. If not, I want to use a different layout. Maybe, if it's a small mobile device, I want to use a bottom navigation bar, but if it's a bigger, you have more space, then you might want to use a sidebar just based on how much screen space you have. We'll go more on like why you would want to use this over like say layout builder. Layout builder, like mentioned earlier in the slides, it's pretty much the same as media query in terms of its use case. But the thing is that instead of giving you the information of the entire screen, it only gives you the information of its parent. So it constrains it. So if you have a sized box or something, you can only adjust what it the response inside that container. And that's the major difference. So here we can see that we'll show it in the demo, but essentially we're changing the amount of columns for images on the screen based on the container size. And then onto responsive package.
Yeah, so responsive framework is a package that allows you to make your UI adaptive. It's essentially like a set of widgets that pre-built widgets that you can use to change certain parameters of those widgets to have your UI be responsive in the sense of by changing the amount of size of the width of the screen. It will allow you to create a certain breakpoints. So breakpoints are essentially like anchors which help the code know that, okay, we've transitioned from a mobile screen size to a tablet screen size or to a desktop screen size. So essentially what breakpoints are. As you can see over here, we'll explain that in the code as well, but you basically declare breakpoints in your main file as a global variable, and then you just reference all of those breakpoints in your code and make the UI responsive that way. Next is basically the difference between Aditya's thing.
Alright. So yeah. So we compared all three of them, and like as Kim mentioned that we'll go through them on which particular scenarios you would like to use either media query or layout builder or responsive framework. Firstly, for media query, there's like a pro and con to it. It's like you have like the access to the entire screen coordinates at once. So which allows you to globally adjust like different widgets, how they're looking on the screen. But then it's also a drawback that you don't get that precision on how to take particular widget and have like a condition on it on how much it should scale or not. So usually it's also media query is pretty simple to understand. It's usual like you use like an if and else statement. If you would have seen the code, it's just like if the screen size is smaller than this, then you go ahead and use like bottom navigation bar should be something of this scale or something like that. The issue, the disadvantage with media query is handled by layout builder, where you are able to gain a lot of more precision and control over like different widgets and how big the widget should be. But what it loses is the entire global screen context. So it can be relative, but then you won't know exactly where, like what different global coordinates are. Finally, for responsive framework, it's like a good mixture of both, where you can set up breakpoints and have different widgets different widgets custom for like different layouts, and this would add a little bit of external dependencies, but what it gives you is like more granular control over what different kind of widget should look like. There's something called responsive row column, or as we saw already, like how should like bottom navigation bar look like in maybe 0 to 500 range, and how it should look different in like maybe 500 to 1500 particular that particular, what do you call it, width. Yeah. So more granularity, and also you get the global coordinates over here. So we'll jump to the code, and we'll start off with the media query.
Can you just make your screen size a bit bigger, like with Control plus? Font size bigger? Yeah, that's too much, but yeah, that's good. Good?
Alright, well, while that's building, this is a very like simple use case of the. Oh, we'll get that in a second.
You can just minimize that.
Yeah, of media query usage. So essentially, all we're doing is when we're building this home page, we're just using this media query size of the context, and you just get the width. Note that you can do media query of context.size.width, but it's recommended by Flutter to not do that if you only want the width, because if you use the .of, you're actually grabbing everything about the context and then you're filtering it down to just the size. In this case, you're directly just grabbing the size, so it's much faster. And then depending on what the screen width is, we set our navigation widget, which we just declare as like, hey, we're gonna give you, it's gonna be a widget. And then when we actually build it, we say, hey, if the screen width is a certain, within like greater than a certain thing, use this navigation widget. Whilst if it's like smaller than a certain width, then we'll use the bottom navigation bar.
You can just go to developer tools. You can just click inspect and we can click change. So if you can see, this is like the whole desktop layout. Desktop layout has like the sidebars based on the media query, and once you like try shrinking the size, it changes to a tablet view, which basically just has like icons for each of those. And once you shrink those down to like the smartphone level, you get the bottom navigation bar. So this essentially is done by the screen size. Like we've specified, like under 600, it should be mobile layout, and that's why it like goes down to the bottom navigation bar. So this is done by the media query part, which basically gets the whole size. The next implementation that we did was using the layout builder. Let me just switch to the layout builder.
Stop the other one first.
Yeah, I stopped that.
Oh, you stopped it?
Yeah.
I'll just run anyway, see what happens.
No, I think just run it anyway.
I don't know, it's just probably just changing versions.
Scroll back so you can explain.
Yeah, okay. So similar to the media query and like how we've talked about like multiple times, in this case, like in the like our media gallery app, I'm just putting like a padding around this responsive image grid, which contains our layout builder.
So it's basically like a grid of images placed one after another, and
Yeah. So essentially, like depending on the size of, say, my padding here, I'll get a different. The constraint for my layout builder will be different. Like the length of it will be different, and then based on that, I set the number of columns that I want for this grid view. And you can kind of see it here. So if the grid size, if the constraint of the padding is big, then we have 4 columns. But if it gets smaller, then we have 3, or smaller, we get 2. To kind of showcase that it's like not dependent on the screen size, but the actual size of like its parent. Then in case here, sorry, yeah, probably make that more prominent.
If you put the padding to like 500, 600 or something, then you will see even in the large screen you get only.
Yeah, so even in the large, you'll still get 3 here. And in this case, you would get 2 because it's based on its parent, not the entire screen. So that's layout builder, I guess.
So the layout builder gives you this constraints class, and from there you can get the min, max, width, etc. And then you can decide what you want to do with it. That's just a Flutter primitive. Yeah.
Yeah, exactly. Okay, cool. You can do the responsive framework. Yeah, that's fine. Just type in something.
All right. For responsive framework, as we discussed, right, we get to choose like different kinds of breakpoints on how the particular widget would be controlled on the basis of like different breakpoints that we set by ourselves. So as we and this is in the main file. This is we are setting globally what the breakpoint would look like. So we are setting up like 0 to 450. This would be like a mobile size, and then 450 and ahead till 800, it would be like a tablet. Ahead of that, it would be a desktop size, and if your screen size is bigger than, let's just say, 1920, which is usually what we consider as desktop, then it would go more towards like 4K. And that is how the how the window size would affect the widgets. And so this was declared globally, and whereas then we call this, and on the basis of this, initially we set up like what we are showing in the example over here is like, do we need to see the sidebar or like the bottom navigation bar? And so on the basis of like context larger than like, let's just say we chose tablet. If it is larger than the size of tablet, we have like a sidebar, and otherwise we would have like, for mobile, we would have like a bottom navigation bar. So that's what we are setting over here. If this is true, if show sidebar boolean is true, we'll build a side navigation bar, which has like multiple buttons that we are also building in with it. Whereas let's just say if that condition is false, which is again dependent on the breakpoints that we set globally before this, we'll build the bottom navigation part. So it, as we said, that this is more precise, more granular, and we can play around with it. Let's just say if we have more different sizes that we want to tweak for, we could do that using breakpoints. So as you'll see, this is a desktop size, and then as you go down, this will go to tablet, and we'll get a bottom navigation bar. And as you go, wait a second, I'll just do, and maybe, yeah. So as you go, like, this would go to mobile. So this is how like you'll see like how the different kind of changes. The sidebar we are changing on the basis of different breakpoints that we have, and if you move ahead, it would be like, we can't show more than desktop as of now, but yeah, something like this.
Okay, so there's a more granular approach that we can do using breakpoints. That I'll quickly brush over it.
Next team, start getting ready. Whoever is presenting. I just want to say something.
Yeah.
Let him finish first.
This is the more fleshed out one.
I don't know more basic stuff.
So as you can see, we've built this UI, and based on the screen size, when you shrink the screen size, what happens is the responsive UI, we use the breakpoints to resize the image based on your screen size as well. So you can't just like trigger breakpoints just to like change layouts. You can also trigger to resize or auto scale based on your screen.
So this is very important. Pay attention to this.
So
because this gives you, one second, this gives you the ability to precisely say, for example, I'm designing my screen for 800. I'm making sure everything is fitting perfectly at 800. The moment it's like 802, it's not going to look nice. Then you put it at 800, and then between 800 and 1000, you put it into an auto scale mode. So it basically, when you go to a 1000 screen, it will automatically scale everything from that 800. So whatever your very tight design was, it's not going to get distracted. That's crucially important part of that what he's talking about.
yeah. So on here we have the text and your images as well. So when you shrink it down to the tablet level, it starts to shrink, and after a level, you see the transition from here. It basically auto scales it to keep it the same size as the original image. And also the top app bar, when you shrink it, it automatically wraps down to the next level, so it doesn't collide with the title bar as well. So when you go down to your phone level, it basically collapses onto itself and turns into a drawer, so it becomes much more as a friendly UI kind of thing. We can just change it from a phone to a phone, so you get better idea. So the image automatically scaled down to the level of what we had earlier on, and then we have the text also being auto crop down.
But you can also auto scale the entire page.
Yeah.
Can you go to the place where the material app you're calling in the code? I want to say something.
Yeah.
So right there.
Yeah.
So what you should, can you undo this?
Yeah.
Yeah. So what's important here, guys, is the material app. We normally don't call the builder. So pay attention. With the material app, we don't call the builder. The builder assumes that it just pushes the home page, whatever it is, without interfering with it, right? The material app just pushes whatever home page I'm giving it, or if it's a router, the initial route. But I have the option to give the material app a builder. So the material app is going to push a child to it, right? The child it's going to push is a home page, but I can specify a builder which needs to get the child, okay? But then it puts things around it. What this does, basically, is a state management based on screen size, right? It's basically, we're defining the states here with the breakpoints, and then every time the breakpoint comes to a certain, or into one of these things, or goes above the threshold, this responsive builder, I mean, it's a builder. The responsive builder says, okay, we've changed state now, I'm going to rebuild it. And that state of the breakpoint you can read from inside the app anywhere, you know, because which breakpoint I am at or which regime I'm at, you can read. So this is an important way to, you know, to get your head around it, that this is effectively a state management that's injected into your material app through these breakpoints, and then you don't have to worry about what breakpoint did I use in that layout builder on this page, because you have 10 pages with different scaffolds. So all of that is fixed and one go. So in every scaffold, you're gonna change to the rail navigation or bottom navigation at the same window size, okay?
So you want me to explain the code as well?
Huh?
You want me to brush over the code?
I think we're good. You know, there is enough material that you guys have put. That was a very good presentation. Thank you very much.
Yeah, so we've also uploaded to GitHub, and I think Professor will upload.
I will put everything into the Camino, yeah. Thank you very much, guys.
Thank you.
Very good. Who's next? You guys? Oh, great. And what are we hearing now?
Isolate.
Isolate.
Yeah.
Oh, one thing. When you're doing your app, I would like you to run the app also once in a tablet, okay? And check how it sees, and maybe at least, you know, 1 or 2 page, you know, handle the view based on this, you know, screen size, breakpoint, and so on and so forth. You know, you know, if I run it on a tablet on a landscape mode, and the thing looks ugly, it shouldn't. You know, just, I mean, I know you don't have time to all of that, but one screen, at least you should fix it with the responsive. I mean, not responsive, but make it responsive. Yes, thank you. Start.
Okay, our group will talk about what is isolate. Firstly, we should talk about how data runs. And the Flutter apps do all their work on a single isolate. That's the main isolate. And all that code runs in isolates. They are similar to threads, but the difference between them is the isolates have their own isolated memory and event loop. So isolates do not share state in any way and can only communicate by messaging, like a send port and receive port. And the isolate allows for simpler programming and is fast enough that the application's UI doesn't become unresponsive. And then we will talk about how isolate works. And each isolate has its own memory and its own event loop. The event loop will process the asynchronous events in the order that they are added to the event queue. On the main isolate, these events can be anything from handling a user typing in the UI to executing a function or intensive task. We can see this picture, and this is a main isolate, a single isolate. And in the main isolate, it will deal with the synchronous events. And about the asynchronous events, they will managed by event loop, and they will put them into an event queue. Like there are three events in the event queue. That the green one, the three green ones, and that is one is repent, and two is process tab, and three is repent. And when they finished, they will go back to the main isolate. And we'll talk about key steps of the Flutter event loop. And firstly, the main isolate will deal with synchronous task execution. But when they met asynchronous tasks, they will handle it by the event loop and in the task queue and add it to the task queue. And then when they finish it, they will render it into a main isolate. And like we list the example. And firstly, we print start, and then we delayed synchronous task, and last we print end. And the asynchronous task will be put into a event loop, will put into an event queue and managed by the event loop. So finally we get the output. That is, first we get start, and then we get end, and then we get the async task complete. That is done by the event loop. So the above example is the one single isolate, but why we use multiple isolates. And the first is to avoid blocking the main thread. And the second is achieve a true parallelism. And three is to optimizing the background tasks. And the fourth is it will be useful for high performance app. And that's our teammate to talk about when to use isolates in Flutter.
The next part is when and why to use isolate in Flutter. And first, we want to introduce the conception of UI junk. The UI junk refers to the lag or stutter in the UI interface that occurs when the mean isolation handles the UI rendering become overloaded. And in Flutter, the goal is to maintain a smooth and responsible experience by rendering at 60 frames per second. Each frame should ideally take no more than 16 milliseconds. However, when the mean isolate is pretty busy handling a heavy or time-consuming task, like processing large data files and applying complex image filters, it will struggle to render each frame within that 16 millisecond window. As a result, it will fall behind on render frames, and user experience this delay as lag or choppiness in the interface. And for the common use case for isolates, the first one is data processing. Like when you deal with the large data files, such as JSON file, are best parsed in an isolate to avoid blocking in the main isolate. And the second part is image and media processing. Tasks like apply filters or resizing images are computational expensive. So
moving them to an isolate ensures the UI maintains responsible. And the third is complex computation. The calculation requires also significant CPU resources like the financial models or scientific computations are also a good candidate for using isolate. And we can also see from this graph and the solid line represent the exact frame time. Ideally, it's the 60 millisecond intervals, and the dashed line represent the actual frame times when a heavy task is blocking the main isolate. And we can see the gray shaded area highlights the frame gap, which causes visible lag. And there's also another charter to let us see the expected and the actual frame time gap. And the red shaded area represents a significant delay caused by the heavy task. This delay will result in a junky user experience. And so why are we use isolates for heavy tasks? By using isolates to handle CPU-intensive tasks, the main isolate can focus on rendering the UI smoothly and responding to user interactions in real time. And it also helps prevent frame gaps and ensuring a smooth and responsible app experience. Okay, let my teammate to show the.
So as we have discussed, unlike traditional threads, isolates do not share states or memory with each other. So how do they communicate with each other? When isolates need to communicate, they do so by sending messages. These messages are typically copied from the sending isolates to the receiving isolates to maintain isolation. This ensures that any data passed to an isolate remains unaffected by modification in the originating isolate. Immutable objects such as string or unmodifiable byte arrays are an exception to this rule. They are passed by reference. The primary method for communication between isolates is through messaging passing using prot objects, specifically send prot and receive port. And receive port acts as receiving channel for messages, similar to a listener, while send port functions like a sender. This setup, the receive port listens for incoming data and triggers a callback when a message is received. This structured message passing ensures controlled and safe communication between isolates. When working with isolations in the dark, there are two main types of isolates that need to be considered: the short-lived isolates and the long-lived isolates. Each serves a different purpose and is suitable for specific use cases. So, in the first example, the code snip, it is using isolate.run. This function offloads a computation to a short-lived isolate, processing the sum, and returns the result directly. This is simple and perfect for one-time operations. And for the second example, we use isolate.spawn to create a long-lived isolate. This function set up a receive port to listen for messages. The isolates receive a start message, performs the computation, and sends the result back to the main isolate. This approach allows for ongoing interaction with the isolates over time, making it ideal for background tasks requiring repeated communication. I'll show the demo code for the isolations. And this is my home page. And when I click start, and you can see I put a GIF picture on the main page, and you can see it keep running. And this is my main user interface. And I got 3 buttons here, and task 1, task
2 and task 3. And for the task 1, I make here's the task 1. I make it do a calculation to add up from 0 to a very large number, which is very CPU consuming. And when I click on task 1, you can see the UI has stuck, and you can see like it gives the result, and after it gives out the result, the UI interface keeps running. So
it basically blocked the main isolate, and the main isolate couldn't do any frames on the screen, which it needed to do, and it waited for the calculation to finish.
Yes, and so for task 2, I try to wrap it with the asynchronous and try if it will work, but actually it don't. Because when I click task 2, it's stuck again. So that's because async do support concurrency, but it allows the program to handle the multitask without waiting for each task to complete sequentially. But if you give it a very CPU consuming task, it have to wait until the task ends and to process the next task. So when we use async is when we have to wait they can wait for the task to complete while other code continues to run. And if we want to run a CPU consuming task, a very complex task, we have to put the code inside our isolate, which supports parallelism, and meaning it can run tasks in the truly separate threads, and which has its own memory, and which is you can see here we create a receive port here. We create a receive port and run a isolate.spawn and create a isolate for the complex task 3. And when we click on task 3, the UI interface doesn't stuck, and it will process the calculation in the background, and until it's done, it will alert the user with a snack bar underneath. And actually, we can click it multiple times, and you can see on the left corner there's multiple tasks running simultaneously, and it doesn't block the user interface. And it will it doesn't matter how many times I click on it, and it will pop the snack bar under it.
So just to interrupt. So basically, the important thing is to understand between async and this one. So async, we can also do unawaited, right? If we do an awaited async, we're going to be blocking everything. We're just like waiting for the result. But if we do an unawaited async, it's effectively running in the background, and it can then, when it's done, it's going to say something. But the async is still running in the main channel. Now, when is it enough to run the async? If the async is, for example, communicating with a database. Because the async process that communicates with an external database is going to send something, and then it's going to wait maybe for a second for a response to come back. But during that time, it's not going to block the CPU. So that type of async, it may take a long time overall, but it doesn't take that many CPU cycles. But an async that would be, for example, processing every image on a huge JPEG is going to, take all the CPU cycles it can. So there is no difference, like calling it direct versus async, because everything is going to come together. So the isolate what it's basically doing is it's putting the responsibility to the operating system, right? It's taking the responsibility from the thread of the Flutter. It's putting it to the operating system, and telling the operating system, dude, you have so many CPUs, cores, run it on one of them, right? That's what he's basically saying, because the other one is used up by this one. So I think this was great. I mean, do you have a lot more, or can we go?
That's it.
Because you did very, very well. The demo and everything is fantastic.
So yeah, so the async is only just run all the tasks on a single thread. Just like the async helps to rearrange the order how they run it, but it is also on a single thread. And like the isolate just put task on separate memory and give it to run, and just when it get back, it receives the message and it alerts you you can perform task when you receive the message. Like here I receive port listen, and when I got the message from the task 3 and it tells me the task is done, and I do the print on the console, and I display a snack bar to alert the user. Thank you.
Very good. Very good. Amazing. And who's next? Then we'll take a look. You guys are next. And what are we hearing from you?
Json serialization.
Ooh, okay.
If I had a penny for every time I do that.
What?
If I had a penny for every time I have to do that.
Do what? Json.
Serialization.
It's
Actually, today I work on a JSON serializer. Yeah.
I mean, these are all extremely useful for your apps, So, and I think one of the part of this exercise is that one team gets really familiar with this technology or with this concept. So when you get stuck in your app, you can just go to them and ask for help. That's another benefit. But I mean, no, it was really nice that you guys got into the responsive frame. These guys cracked the isolate. You guys did, what did you guys do? The other
Wow.
Hey, hang on, I'm going to remember. Animation, yeah.
Yeah, there we go.
Except you had a bug. You had one bug. I'm not going to remember that. I'm not going to forget that.
Hi everyone, we're group 7 and today we're going to talk about JSON serialization in Flutter.
Crazy.
So as the name suggests, JSON serialization would involve turning a data structure, any kind of data structure, into a JSON string. So your data structure can be on the simpler end, like a list, or it can be on the more complex end, like a user-defined object. So whatever serialized data you generate from that, you can transfer within your app, like between the Dart objects, or between the app and any other external source, like a RESTful API or a local storage. So a lot of apps have turned to JSON serialization these days for a variety of reasons. So the first reason being that JSON is very compatible with different platforms and languages, and it's used as a sort of universal model of data transmission. The second reason involves the fact that JSON structures the data in a very clean and compact way, and it's very intuitive for users as well as developers to understand. And the third reason being is that it's used for a variety of use cases. So for apps, when they handle persistent data such as user preferences or app configs, JSON is like the go-to format for that sort of purpose. And for example, if your app involves fetching data from the internet, for your HTTP request, JSON has become a sort of go-to method for structuring the kind of data you want to send as part of that request. So keeping all these pros and the basics in mind, so today involves discussing how to implement serialization and deserialization with JSON first we'll talk about the manual approach, and then we'll head to the automated approach. Then we're going to discuss how to handle complex cases like nested or inline JSON, and how to customize for certain instances. And then finally, we're going to talk about the best practices involved for serialization, so as to avoid any common pitfalls of that. It's not there, it's not there.
So moving on to the manual approach, this approach involves writing custom methods without using any automated approaches or code generation tools. And typically, this means that you would create a to-JSON or from-JSON method.
Go on, I'm just trying to
yeah.
see if I can help with this.
The to-JSON method will map the object's properties to a JSON-compatible map, and the from-JSON method will reconstruct the object from this map. And this particular manual approach requires writing more code, but it also gives the programmer more control over the whole process. So we would suggest using this approach if you're writing a more simple app and you want full control over what you're doing. So starting with the manual serialize function, you can see we have a student S1 object that we created, and essentially what we're doing is calling the to-JSON method that I showed somewhere. Right there, yes. And the to-JSON method essentially maps each property of the student object. So you would get the ID, name, major, and GPA. And then the keys are the property names, and the values are the property values. And this map is JSON compatible and can be on-coded, which we eventually do over there. And the JSON on-code function enables the conversion of the object to a JSON string, which you'll eventually see once we show our demo. So moving on to the deserialization process, it's essentially the reverse of the serialization process. The student object is again created and serialized into a JSON string through JSON on-code. And then this JSON string is subsequently decoded back into a map string dynamic using JSON decode. And then we want to reconstruct the original student object. So we call the student from JSON, and then you can see the from JSON over there. So essentially we're just doing kind of the same logic as we're doing in the serialize, but just the reverse of it. And the reconstructed object we're going to print, and then we're going to change the state. So you'll see that in the demo. So here is the manual serialize function. Data over here, and then here is the deserialize. So you can see how the data changes through the method. So moving on, next is the automated method.
So while the manual serialization and deserialization is easy to get started, it also obvious drawbacks and disadvantages. When developing the application, the objects may have higher complexity, and it means, for example, there are nesting objects and data objects in our Flutter applications. That means we need to write more variables and complex code to do the serialization and deserialization. And it will be redundant and difficult to manage. Also, when changing the data model and logic, it requires more effort to maintain. So to handle those cases, we find a better solution, the code generators. The code generator is a tool for developers to automate the serialization. In Flutter, there are libraries to produce the code based on the provided data model. So it can speed up the development process and reduce the likelihood of errors. For example, the JSON serializable package, it automates the generation of the JSON serialization code and ensures the data models stay aligned with the serialization logic. So compared to manual methods, we can see the generator is important and valuable for developing large and complex applications.
So in order to make a manual, in order to overcome the manual efforts, we are using automated serialization, wherein which we are using few dependencies. One is like JSON annotation, and the other is Intel, and the other is JSON serialization. So these are mainly used for the code generators. So it reads your class structures and produces JSON conversion methods on it. Next, instead of manually writing out to JSON and from JSON, so we are using here JSON serializable annotation to the class, saving and reducing the time and any errors if there are. So, and we also have a build runner. So it is a tool that runs the code generator file. So we are generating a file that required for the necessary automation or serialization. So I'll be showing that in the code. So these are the dependencies which we have run. So in order to get these dependencies, we have to write Flutter pub run build runner build, so that these all will be built, and there will be a files like a if I say this is the generator file which they will be generating. So next comes JSON annotation, and this JSON annotation will help provides annotations used by JSON serialization generator to define how serialization works and on its own. Instead, it is used to mark classes or fields as well. Next comes, so how to automate serialization. So we have created a class here. So within the class, we are giving a JSON serialization. So all these this command will help this to create a Dart file, generate a file, which helps to convert from to JSON to from JSON. Once the code is generated, you can convert the data from JSON to JSON directly. Next, what is the advantage comes automatic code generation, and there will be error reduction, and there will be a customization in this. So next comes.
I'm going to explain how this automate serialization work briefly. So as Pujita said, when we add JSON serializable annotation to a class model, so and then we run a build run command, and it gets automatically created this code for serialization, deserialization for the model classes. So earlier, these classes, these methods we used to write manually. So when you run this build command, it generates automatically. So when you run a build command, first it scans all the models which are automated with the JSON serializers. Then based on those classes, it creates these two functions. The first one is from JSON, the other one is the to JSON. When you see like the from JSON will convert a string to an object, to JSON will convert the object to a string. So after creating it creates file name called like file name .g.dot file, which will be included in your main source code. So those files can be that can be invoked into your class files, and you can write wrapper functions on top of those functions, and you can perform this serialization and deserialization with for to JSON and from JSON. If you see this code, here we are doing auto serialization. Here we gave a class object, and we are giving this class object will take it as an input, and it generates class JSON map object. When you give this JSON map object to JSON encode, the dot converter will convert this object to a JSON string, and the vice versa. The auto deserialization, here we give JSON string, and this JSON string is decoded by the JSON decode, and it gives a map JSON object. So this map JSON object we use from JSON automatic method, and we convert it as an object. So here in this code, if you see here for the before, for the manual thing, we used to write functions for from JSON and to JSON, but here we added JSON serializer over here, and it creates the class name .g.dot file. Class name .d.dot file. It automatically creates from JSON and to JSON methods. If you see here, and if you as shown in the PPT, if you call those functions, and here if you click serializable, if you give a object, it converts into a string. For deserializable, if you give a string, then it converts to a object. Next will be continued by.
So now when it comes to handling the more complex structures, one of the more commonly encountered complex JSON structures would involve nesting, and it's used by a lot of apps these days. So for either case, it's very complex to handle, mostly due to depth and or possible variability. So in such cases, there are two things to ensure. So the first thing is that whatever data models you've defined for your app, they should be as realistic as possible. As in, they should align with the kind of data structures your project or your app has to ideally use. And when you're creating a nested structure, each level will correspond to a different kind of Dart object. So the second basic requirement is, of course, the annotations as discussed in the previous examples. So if your models are annotated in the right way, JSON serializable can handle these nested or inline structures without encountering any errors whatsoever. So this type safe indexing, which we haven't covered in this implementation. So if you want to carry out type safe indexing within a nested JSON structure, there is a package called the deeppick package which can be used. So where you use the regular brace-based indexing methods, the pick method can be called from this package, and the input string as well as the various levels can be passed to that method so as to ensure type safe indexing. So in the example we're going to demonstrate now, so the student structure that we've created before, it's very similar to the previous one, but only this time we've added a field credits of the type of the object type credits, which is defined over here. So credits is also annotated with JSON serializable, and it requires 3 integer fields, and it has its own predefined to JSON and from JSON methods. So now this particular object is used as a field within the student nested object, and I'll be demonstrating how this works. So right now we're just using automation to carry out the to JSON and from JSON from the nested structure. So if you can see, so this is for the nested object, and like I said, this is the structure it takes on. And these are the two, this is the two from JSON method, and it will call, for credits in particular, it will call its own predefined from JSON method. And this would be the toJSON, which would convert it into a JSON string. So once you run the build runner command, it will generate the .g.dart file, which here will define all the basic toJSON and from JSON methods. And this will be in turn called within these nested serialize and nested deserialize methods right here. So we've predefined our nested structure, and we're calling the required methods, which I will be demonstrating right here. So here you can see the nested structure generated as a JSON string, and the credits itself will be generated as like a JSON structure within a JSON structure. And deserialize will generate the entire object itself. So now we're going to talk about customized cases.
So coming to the customized cases, we have we don't need a few structures to be removed, or yeah, sure, Professor. So to be removed, and few can be null values. We need to add data to it. So for that, we are using custom cases. So in this custom cases, so we are having so we are giving a null value for the GPA now here, and we are hard coding the value as a 4.0, and in the end we can get the value. And view address has some null values. So if you are giving null values, like we are calling here like required this will give you an error stating that is mandate to call. So but it has null values. For in that case, we can use some JSON keys as for us. So one of the JSON keys is include if null, and the other thing is so here we can ignore few columns as well. So for ignoring, we can use include from JSON false. Previously it used to be ignore true, then the column will be ignored. So now we are using, that has been deprecated, and now we are using include from JSON to be false, so that the password will not be shown here. So if I run this one, you can see here. So serialization, I said that GPA has been hard coded, and it is showing it here, and the password it is not showing in the string format. So when it comes into the deserialization, it is a clear value. So address is I'm passing it null, and GPA even though if I'm passing it null, but in the main function I'm hard coding the value so that it is reflecting it here. So this is how it works with the custom cases. There are more custom cases, but I have given a few examples of it. Thank you.
Very good.
So finally, here are some practices that are helpful for developing the serialization and deserialization. You can use strongly typed models, handle optional or missing fields well. Annotations are essential. We need to specify the annotations well. And prepare for the unexpected or poorly structured JSON. Remember to define the exception handlers that catch errors. Keep the serialization logic up to date. As the application grows and evolves, the data structure might change. Test and maintain the serialization code properly. Write proper test cases to help ensure that the serialization logic works as expected.
Thank you very much. Very good. Any questions?
Stuff, you know, like when you add the annotation for the serializable, if you change one of the fields in the class, is it gonna like propagate those changes to the generated?
Yes, it will.
Okay.
It will.
That's cool.
Yeah, so it depends on what kind of setting you're doing the build runner command on. So if you not set the watch mode, you'll have to run it every time you manually change your model. But if you do set it to watch mode, it'll automatically run as soon as you update the code. So yeah, it really depends on that.
So yeah, do you want me to show the output, Professor, by changing it and running the code?
Let's move on because I think we have other things to cover. But this was very good. So I'm going to put all that code and everything to the So guys, let's take 5 minutes break and then come back fresh. 8:20, please, let's come back at 8:20 to the room. And then we have 40 minutes to talk about FutureBuilder, StreamBuilder, Firestore, data indexing, a few things.
ఎదుక్కుంటున్నా లాగిన్ పేజ్ చేసాడు బుక్ యాప్ ఎత్తుకోరు లాగిన్ పేజ్ ఎత్తుకుంటున్నాడు
So how do you start that? You told me?
Start.
So, well, I mean, starting point is student.dart, right?
Yes, so if you scroll up there, so first you have to put the serialization that happened. And then these methods, you will have to annotate with the underscore the dollar sign. That if you want the build runner to understand that, or that will be generated package to understand that. So that's how you annotate the kind of. So once you run
Oh, wait a second. So, this is where you start your class, and then you define your, okay, so you define your from JSON to JSON, point to the underscored methods.
Yes.
And then you do and include g.dart file over there, so that the g.dart file gets automatically created, and then it points to that internal function, the underscore. And what the g.dart is creates the underscore, but you still have to build your own, I mean, you still have to define your to JSON and from JSON methods.
So this is for manual.
So these were for the manual approach.
So this is for automatic.
I know. But let's say you don't do any manual, you still have to say to JSON points to this, and you have to say from JSON points to this. It doesn't write them himself.
It doesn't write it itself. So once you put these two lines of code, you open the terminal and you run the build runner.
Yes.
And that's when it generates the string.dart file, and it's already
Because
there.
when you first write it, it will give you an error because it says it won't see it. Once you do the build runner, it has created that file with those. Okay, I get it. No, that's all. Thank you. Okay. And JSON key, you put basically before every declared parameter, you put a JSON key to put any conditions on it to include.
Yes.
Nice.
And to run this JSON key, we need to add intel. There is a dependency intl, so wherein which it will give the date formats, or it will change date formats and the dependencies.
Shit. Oh, sorry.
But yeah, so like there's different routes if you want to become like a lecturer. But I don't know about like a professor or like grad school or something.
Well, one step at a time.
Yeah.
We'll cross the bridge when we have to.
You don't want to work corporate anymore.
No, I just know that like it might be some calling that I have later in life. So I wanna be like a little bit more ready for it rather than just having it in the moment and not be prepared.
Yeah, for sure. I think when I'm a little older, I want to have like a school back in my home.
Oh really? Oh.
It's like third world, so I feel like opening up an engineering school or something like that would be nice.
I agree. I think education is the key.
Yeah, I agree. So.
Oh, you're making the login page?
Yeah, basically, I've done the bootcamp with Guru to previously. So I'm using the same code for the page.
I think so, yeah. I think if I would do a school, I think I would try to add a little bit more philosophy into it. It's like today when you go to school, all you learn is how to make money, but then later in life you're like, oh, what is the meaning of everything? And then you're depressed at home and really never thinking what's more.
Oh, we're talking about like.
Which is insane. I actually came.
Shall we start, or are we missing?
Go ahead.
Maybe we can start. Okay, guys, let's cover this stuff. Now, FutureBuilder. What is FutureBuilder? Is basically you have you have some feature that's going to bring some data in a minute, and you can handle this obviously with the qubit and all that structure we did, or with a stateful widget. But there is a FutureBuilder widget which Flutter is giving us that allows us to do it very simply without having to bring stateful widgets. So let's think about this future, okay? So this is a small function, get data. It's a asynchronous function, okay? And what it does is that it waits for 3 seconds, and then it creates 20 mock users and returns them, right? So we know that this function is going to run for 3 seconds, okay? And it's going to return users. Now, how we use this FutureBuilder is like here. So this is my widget, FutureBuilder. It needs the future. So you need to give it the future, first of all, which currently has no data. And then after some time, a data will come. So the builder of the FutureBuilder, right? It obviously takes the context, the current build context, but it also takes this, gives us this snapshot, okay? And every time the FutureBuilder, something changes with the FutureBuilder, something happens, we have access to this snapshot and it gets triggered, the builder gets triggered. So the builder gets triggered immediately when the widget is painted on the screen, and obviously this snapshot has no data at that point. The future has not resolved, future has no data. So then this asking it whether it has data, it's going to be negative. So therefore it's going to return a container with a circular progress indicator. So initially when I paint this widget on the screen, it has no data, the snapshot has no data, it just gives me a circular progress indicator. Then the builder gets triggered again with the snapshot, but this time snapshot has the data, okay? And then it basically puts the stuff I wanted to put on the screen, which is a user list with a user list style like this, okay? And the code for it is here. I mean, you have it as well, obviously, in the thing. Let's just go to the FutureBuilder page. Yeah, so this is the code. And if I restart my program, it says fetching data, progressing, and so on. So this is whenever you have like something that's returning a future, rather than building a whole infrastructure of qubits and stateful widgets and so on, you can just bang this in there and deal with the future. Any questions on this?
I do.
Yes.
How does the I think this might be not that relevant, but how does the await async and await keyword works? Is it the compiler breaking it down into like a machine state? Like I don't know if I'm explaining it correctly. So the compiler will take the code and break it down by every statement that you do await, and then it returns a machine state that once one task is completed, it goes into the next one. But while it's waiting for the future to be completed, then it yields the control back to the caller. Does that not apply?
But that's generally how it's. I mean, there is no. This is not dealing with the future. It's basically think of it. Think of it like, this is, at the end of the day, behind this, there is a stateful widget, right? So a stateful widget, it needs to repaint itself. And the FutureBuilder, it just combines everything, and you're running a asynchronous function, and you're in the stateful widget, you run the asynchronous function unawaited. But the asynchronous function, when it's finished, hits the set state. Right, so it repaints itself. So it's effectively the same thing, but compacted in a slightly different way. Okay, so it's very similar to StreamBuilder, which we're going to see in a minute. Let me go to the screen. Yeah. So. Yeah, that's the thing. So we can of course build this with the qubit structure. So we could emit a loading state while we're getting the data, and then show a spinner, and then when the data arrives, we could emit a loaded state, etc. But the FutureBuilder is just a quick way to do this without building a lot of things. Now, the next thing, let me pull my code. It's not a big problem. Let's read about it first. Okay, so for the StreamBuilder, we're going to be using Firestore. Okay, the connection to the Firestore from your telephone, if you build a connection, a persistent connection, it happens through WebSockets, and your computer starts listening to the Firestore. And if there is any changes to the thing that you're listening in Firestore, you get it as a stream. Okay, so in Firestore, I create a collection called cities, and so we have a list of cities to start with in Firestore. It's still running. Oh, this is so painful. Okay, we have this collection in Firestore. So the next thing is we have to add Cloud Firestore to our library. And then how does the StreamBuilder work? Okay, the StreamBuilder, first of all, needs a stream. Okay, and in Firebase, the way we define a stream is instant.collectionStreams.snapshot. So basically, we define the address, right? That's the address. So cities collection. So everything in that cities collection, and then .snapshots gives us the stream. And obviously, what this widget is going to do is going to be listening to that stream, and every time something changes in that stream, it's going to repaint itself. And it's going to expose the snapshot, again, just like the FutureBuilder. I'm checking whether the snapshot has data. But this time, with the FutureBuilder, snapshot starts with no data and then ends with data, and that's it, right? In the FutureBuilder, there is only two states, initial state and future has completed state. But with the stream, there is the initial state when we're waiting for the first package to come on the stream. So that's the has data state. But then every time there is something else coming on the stream, it triggers the builder, right? Every time it comes the build. So if it has no data, so if it has data, we do a list view of the cities, and if not, we're returning the circular progress indicator. And what is happening with my Xcode build? So now this, to be able to paint it on the screen, let me go back. To be able to paint it on the screen, I'm building, in the list view, I'm building some text widgets, right? And the way I'm building it is this, I'm checking the snapshot.data. That's basically the contents of the stream at that point, right? And then the stream itself is a query snapshot, okay? Which has documents. So documents is a list of query snapshot doc objects, and then I'm mapping those documents to text widget by calling the data method of the doc. So if you go to this page, it's easier to see. So I'm calling the data method of each doc that comes in the snapshot.data, and I'm printing the name property on the screen. The demo page, where do I have to show this? Okay, let's stop this and let's try Android. I don't know. So in this screen, which you're seeing how it works, I've something called the city entry, and city entry is just this widget, okay, which actually injects a new city into the Firebase, into Firestore. And if snapshot has data, I have this list. If not, I'm returning this Shimmer list widget. That widget is going to be also together with the Shimmer. I don't know how it got there, but we're going to talk about this Shimmer in a minute. But let's say this is the circular progress indicator. So if I add this thing, because I'm constantly listening to the stream, this data is coming back from the Firebase. And the data entry, okay, to Firebase, I'm doing with that city entry widget, which has a text field, right? It has a text form field. It has a onSaved function, which calls the Firebase Firestore instance. It calls the collection, and then it adds the value to it. Okay, so that's how you add the thing. The reason I'm using the text editing controller in this little widget, so the only thing that this widget has is a form with one text form field and a button. The reason I'm using the text editing controller is because after I have called the form key save, okay, I want to empty the controller. So I want to empty whatever is in the text form field, and the only way I can do it is with that text editing controller. Okay, so that's why I have that. And then in the dispose method, I have to get rid of the text editing controller. So let's see if we will be more lucky with the Android. And what else is there to talk about? Yeah, so that basically, we're inserting into the cities and seeing it's working fine. So the other package, which we see a lot in internet, right, or mobile phone everywhere, is this Shimmer package. So when you're waiting for some data to arrive, you don't want to show a circular progress indicator, but you want to show something that resembles the data that's going to come. So that's the key. Whatever data is going to come, let's say in this case, we're going to have a list of items. You show this thing in that Shimmer package, and so the user at least waiting something with anticipation of what to get. Whereas the circular progress indicator doesn't give confidence to the user what's happening. But this tells the user this is something like that you're going to get. Obviously, if it's if you're sending some kind of a card with a title and a content and an image, you should make these things similar to a card with a box of an image and then a thin title and a bigger content box, etc., to give people the impression that they are going to be filled in a minute. And the way we do this is by creating a Shimmer list widget. In this case, what I have is I have a column. So this is what you have to focus on. I have a column of containers with a little bit of a margin. So containers with a little bit of a margin have a width of 200, height of 15, and have a decoration of a rounded rectangle border with 2 border radius, okay? So I have these little labels that are my placeholders for my thing. And this is the child that goes to this Shimmer widget. So the child that goes to the Shimmer widget is the form of the widgets that you want to see on the screen. Then, by wrapping the Shimmer.from colors around it with this base color, highlight color, this these that run across, the highlight color is the light gray and the base color is the gray. It basically takes over the underlying widget, right? The underlying widget is a white container with the rounded corners. It takes it over and creates this, okay? So that way, when we look at the StreamBuilder, the way you do your StreamBuilder or even a FutureBuilder is that if Snapshot has data, you know what to show. You're going to show the data that you need to show. But if it doesn't have the data, you return this Shimmer list widget, okay, while it's trying to get the data. And you can do the same thing for the FutureBuilder, okay? So that's the sort of standard practice to do these things. So our demo is running, luckily. So if I let's have a look at the Firestore as well. Okay, so this is my cities collection. And I add a city here. It's not going to change the screen. Oh, it actually showed us. So we've seen the thing inserted here, and it updated the stream. The thing is, because the stream connection is very fast, we're not seeing any of the Shimmer effects. When I restart the code, I'm not seeing the initial Shimmer effect because it immediately gets the connection. But what I can do is I can force the shimmer. Oh no, this doesn't have the shimmer. Okay, so now I have the shimmer in the background. I don't know if we're going to see it, but let me refresh the screen. So briefly, the shimmer was shown. Did you see? So to force it, I'm going to force this, I'm going to change this here in the StreamBuilder. If snapshot as data, I'm just going to comment this out. So that's how the shimmer will look, because I've just overridden this part. This is how the shimmer will look, and you will have this this feature in the thing. And any questions on these FutureBuilder, StreamBuilder, Shimmer? No. Okay. Then I'm going to move to the Firestore part, and we're going to look at the code. So I now have the Firestore code. So we're going to look at what type of things we do with Firestore. So let's look at what's happening in this page. So in the init state, when I first call this page, I call this function initializeDB. And what does initializeDB do? It creates a futures list, empty. Okay? It creates an empty futures list. I create a query snapshot of users. So because I have a users table, which I'm loading and unloading in this exercise. And this is my reference to that users test collection. I'm getting that users test collection, which is a collection of documents, and then I'm basically looping over those documents in users.docs. I'm looping over those documents. Okay? And for each document, so for each user doc, which is one of these items, I go to its reference, and then I invoke the delete method to remove that document from the database, okay? So this is what I do, but I don't do it synchronously, obviously. I create a future for it, and then I put that future, so this is a future inside, I put that future into this futures list, okay? And there's also this events thing. I'm doing the same, but forget that now. I mean, it's the same thing. But then at the end, I'm waiting for all these futures to resolve. So remember, these futures are not running one after the other. They are running parallel because each of these futures is not blocking the code, the full time. Even though there is like 20 delete commands that are running, it hits the database and it waits. While it's waiting for the return from the database, it can pretty much do other things. Okay, so that's what the initialize. So basically, if I do the refresh, it initializes the database. Did you see this transition? The circular progress indicator and then the transition. So let me show you what that is. So it's a little bit of an animation, and it's this animated crossfade. Okay, so this is a useful thing that you can use to just, to show a nice transition from one to the other. And what it does is it has two children. It has a first child and a second child. Okay, and depending on this crossfade state, it either shows the first child or second child when you hit the set state, right? And this initialized Boolean is one that I set to true after I have done this initialize DB call, on the init state, right? So therefore, once it has been initialized up here, once it's been initialized here, in this initialize DB, I'm setting this Boolean to true, and then I'm calling set state. And in the set state, obviously, the animated switcher, animated crossfade, widget is going to move from the first child to the second child, and vice versa. So that's the animation bit, which we see when we start the thing. It deleted the users. Okay. Now let's create the mock users. Okay. So mock users are created. What function is that creating mock users? That's a simple one. It's this one. Okay. We create mock users and we set the state. And when we set the state, we actually see this number of mock users. The next thing is add users to Firestore. So this button is connected to this, okay? And what it does is, again, we create an empty futures, and this time adding the user, it's Firebase Firestore Instance Collections user test, that's the address, and we're adding the data. So we cannot add the user object, we have to change it to a map. So Firestore requires a map to go to it in this syntax, not a JSON. So we send user.toMap into Firebase. We again wait for all the futures to complete, and then we set the state. Okay, so let's have a look at the Firebase. What do we see here? We didn't call it, sorry. Okay, so it's now being called to Firebase. It's now being put into Firebase, and now I have 10 users, created with this mock user method. Questions? Okay. Now the next thing is, let me do a filter. Right? Not just get everything in it, but let me do a filter. And the filter command for Firestore is simply after the address, you put a where. Okay, so there's different syntaxes for different type of things. There's also array, to check whether something is in an array and this and that. You can read that up in the documentation, but basically, it's the where command that does the filtering. And in this case, I want to get every user that starts with the first name A to K. So it should be less than L. And that's it. So let's get that. So it's got 5 users with the first name less than AK. Okay? Now I'm going to do something. So the next thing is I want to get users with a first name A to K and last name L to Z. So I have two conditions, okay? For two conditions, let's try to run this and let's see what happens. I'm running this with the two conditions and I get an error. So this error is basically saying that it doesn't have the index it doesn't have created the composite index for two fields, okay? For you to be able to do where on both of them, you need to have this composite index created, and it's just telling you, click on this, and you'll create the index. So what you will do, so this is something you're gonna come across. So keep this in mind. So I go to my browser, there was some junk here, and I paste this link in here. And it takes me to the, I cannot move it. It takes me to this index creation page, and basically it wants to create an index between first name and last name. Okay? And I just say save, and oh, index already exists. What happened? But we just deleted it. Okay. Let me see. Maybe I shouldn't have deleted it. Okay, it's fine. It took some time probably to get it started. So basically, you get this type of thing. It takes a little bit of time to build, but not too long, maybe a few minutes, and then you'll have your index. Once that index is there, we should be able to run it without an error and get the composite value out. So the next thing I want to talk about, what time is it? Okay. The next thing I want to talk about is this peculiarity about Firestore timestamp and Flutter date time. Okay? So Firestore timestamp and Flutter date time. And for that, I've created a class called event. Okay? It has a date, time, date, and a title. You know, simple class. Now, the class generator, which gives me a toMap function, it uses this millisecond since epoch property of the date time. Okay? But that's not how Firestore stores it. So if you're talking to Firestore, you need to do something different. You need to create something called a timestamp object, and this timestamp object comes from the Firestore library, and you need to create this timestamp from date and date. So this is the correct thing that you can send to Firestore. So you create. So the way you have to do is that if your class is going to communicate with Firestore directly from the app, you need to create this to Firestore map and from Firestore map properties so that it correctly handles the timestamp. Okay? And the from Firestore map will now, whatever is coming from Firestore map, this is a timestamp. So you need to cast it as timestamp and then convert it to date. You know, you're not going to remember this now. The only thing you should remember is that if you are dealing with dates with Firestore, make sure that you don't do it, you know, without thinking, okay? Just make sure that check what was the syntax, just remember there is something peculiar to it. After you've done it 5 times, you know you will remember it. So let's see if our index is enabled. Okay. So let's enter an event. And let's see what our event has been entered into. So the event was entered as 31st October 23 at 00 UTC -7, which is, wait a second, are we UTC -7?
I think so. Yeah. In Pacific time?
It's -8 or -7. So
What do you mean -8, -7?
Either or.
Either or.
That's a bit imprecise. You'd miss a lot of planes with that. So who's going to explain why this is coming at -7 and not -8? We're at -8, right? In California, we're at -8.
Yeah.
Yeah, we're 8 hours from London, so we're -8. But why is this showing -7?
Daylight savings?
Yeah, because 31st October is still in the daylight saving zone.
Oh, got it.
Very good. Okay. All right. So we've created the event because we have specified the event creation date as where did we create the event? It's not the StreamBuilder. It's in the data page. Yeah, enter an event. We said basically 10/31/23 date time, and it takes my current time zone to create this on where the machine is running. It's a little bit bizarre, but that's how it is. And then read an event will read the event into memory from there. I didn't print it out, but let's just check if this index is now working. The users with first and last name, and there's only one, right? The overlap between users with first name A to K and last name L to Z is only one person. That now shows that indexes work. And okay, I think this concludes today. So all this is there for you to use in your apps. And I'm going to get all the other material from you guys up on the Camino.
Can you please remind us of the purpose of creating
Should we ask the professor to...
Oh, yeah.
I'm giving an example.
Shimmer बना के दे.
How to make sure that
पीयूष में आपने शिमर बना के दे.
अभी नहीं बनाया.
मेरी शिमर
When you create your Firebase, you give a namespace. So if I'm a company called Tesla, my namespace, and it's a driver app, I'm going to give com.tesla.drive namespace. Okay? So therefore, what I'm saying is for that app, when I'm creating the first Flutter file, to have the correct namespace in it, there's a directory called driver.